Last class we have seen the structure of a CR. Basically it's a PNP device, 4 layers, 3 terminals, anode, cathode and gate. Anode and cathode are the power terminals and gate is called the controlling terminal. Now this is a circuit symbol for an SCR. Normally we draw this is anode, this is cathode and this is the third terminal, gate or the controlling terminal. So this is the circuit symbol. Now today we will learn how to turn on this SCR. How to turn on SCR. There are different methods and we will start from the basics and we will try to understand the drawbacks of each method and we will find out an efficient method for turning it on, this SCR. Now one of the methods to turn on the SCR is, we know that whenever the anode is positive and the cathode is negative, which means when you give a supply voltage with respect to anode and cathode this way, so anode is positive, cathode is negative, what is the status of junction J1, J2 and J3? So this is plus terminal, so P is connected to this plus point and N obviously is connected to the negative part, so J1 will be in forward biased condition, J1 is on. What about the status of J2? This is an NP junction, N is connected to positive and P is connected to negative, so this junction J2 is in the reverse biased condition. What's the status of junction J3? N is connected to the negative part, P is in the positive side, so junction J3 also in the forward biased condition. So the thing is, J1 and J3 are in the forward biased condition, which means they allows conduction. The charge carriers can easily pass through J1 and J3, but J2 is in the reverse biased condition. So even though you apply voltage between anode and cathode, SCR cannot conduct. Why? The reason is J1 and J3 are in the forward biased condition, but J2 is the problem. J2 blocks the entire voltage. So this is the reason why even though we are applying a positive voltage, SCR cannot conduct. So since you have understood the problem, this is the reason J2 blocks the entire voltage. How can you eliminate this? Okay, so by common sense we can understand that this junction J2 is having a capacity to block a particular voltage. So beyond that, if I increase the voltage, the capacity of junction J2 also loses and it also allows the conduction. Okay, so I am going to trigger in that way. Based on that, I am going to draw a graph also, and this graph is called the characteristics of SCR. So SCR basically PN, P1 N1, P2 N2, anode and cathode. Across anode and cathode I have applied a positive voltage. Junction J1 is in the forward biased condition. Junction J3 is in the forward biased condition, and this is junction J2 is in the reverse biased condition right now. Now what I am going to do is I am going to increase this voltage. Okay, so I am going to draw a graph. In the x-axis I am taking anode voltage VA. This voltage is VA, voltage with respect to anode and cathode. Okay, and the current flowing from anode to cathode once the device is turned on, that is represented by IA or anode current. So I am going to draw this. Okay, so initially I am going to apply some voltage. Let's say I'll start with 0. I am going to increase to 10, 20, 30, 40, etc. So I am applying 0 volt, nothing happens. 10 volt, junction J2 blocks the voltage, so there is no current. 20 volt, so this is 10 volt, this is 20, 30, etc. And assume that the capacity of the junction J2 is say 700 volt. Capacity of junction J2, say it's 700 volt. So the meaning is, if this is 700 volt, the meaning is beyond 700 volt. Let's say I'm going to supply 701, the capacity of the junction J2 loses and it breaks down. That's the meaning. Okay, so until this 700 voltage, junction J2 blocks the entire voltage. There won't be any current through the SCR, only the leakage current. A very small amount of current flows through the SCR. Okay, until 700 volt. Now if we increase the voltage to 701, the capacity of junction J2 also loses. Immediately the current, anode current, starts to flow through the device. The device is on. Okay, so the moment I apply 701 volt, immediately the device turn on. What is the meaning of turn on? Whenever I switch it was in the off position and now it is on. What's the meaning? It is in off position means it was blocking the voltage. Once it is on, which means the voltage across the switch gradually decreases to 0, it allows the current to flow. That's the meaning of open switch and closed switch. Similarly, until 700 volt, it was in blocking state, it was not conducting. Voltage increased to 701, immediately device will conduct. So when device conduct, immediately voltage drops to 0, almost 0. So this is the state, voltage immediately returns back to 0. I'm drawing like this using a dotted line because immediately it comes back to 0 if it is an ideal device, but it's a practical device, so it won't come back to 0. There will be an on state drop. Like in a diode, it's 0.7 voltage is there. Similarly, in an SCR, a normal SCR, it will be around 1.2 volt. It will come back to this state and depends upon the load. If we are connecting a load here, okay, if you increase the load, the current also increases linearly. This is the graph. This is the current increasing. Okay. So this is the forward characteristics of SCR. Until 700 volt, the SCR was blocking the voltage. So it is called forward blocking mode. Forward blocking mode. Why forward blocking? Forward means anode is positive and cathode is negative. That's why forward. Blocking mode means even though you are applying voltage, junction J2 breaks the voltage, blocks the voltage, so it's not conducting. That's the meaning. Now after that, once the voltage reaches to 701, immediately SCR goes into the conduction mode. So this is the forward conduction mode. So there are two modes of operation for SCR in the forward region, forward blocking and forward conduction. In the forward blocking mode, it acts as a open switch, which means it's not conducting, and in the forward conduction mode, it acts as closed switch. Okay. Now, what's the drawback of this method? Now the meaning is that SCR has turned on. We are very happy that SCR has turned on. Now tell me, what is the drawback of this method? The drawback of this method is that you have to supply 701 volt to turn on this SCR because the capacity of the junction J2 was 700 volt. It's a very high voltage. So assume that you are going to use this SCR. Assume that you are going to use this SCR in your home for a fan regulator. The supply voltage is only 200 volt, right? So to turn on the SCR, you need 700 volt. So for a fan, you have to insert a step-up transformer, right? So large voltage required to turn on this here. So this is not very practical method to turn on. Okay, this method of turning on this SCR by increasing the forward voltage beyond the capacity of junction J2 is called the forward voltage triggering. This is very important. What is meant by forward voltage triggering? Increase the forward voltage. Once the capacity of junction J2 breaks down, SCR will turn on. And remember that we have not used gate terminal at all. So far we have not used, the gate terminal is left. Okay, we will be using only anode and cathode. Increasing the forward voltage, junction J2 breaks down, and this is called forward voltage triggering. So after this point, this is the breakover voltage of junction J2. This is called forward breakover voltage VBO of junction J2. So the drawback of this method is that you have to supply voltage beyond this VBO to turn on this SCR. Okay, so this is a drawback of this method.